Okay, I'm going to solve this two different ways. The first way is I'm going to use the idea that the peak power is twice the average power, right? Or I think in the data packets, average power is peak power divided by 2, right? Now, this is the resistance. There is no peak resistance or anything. It's just the resistance, right? But that's my peak voltage, right? So my peak voltage is 172 volts, right? Okay, so therefore my peak power is going to just be V squared divided by R, right? There is no peak R, right? But there's a peak voltage, right? So 172 squared divided by 12.2. So 172 squared over 12.2. This will give me twice the power, right? That's 2424. 0.91 watts, right? And then if I just divide that by 2, right? If I divide that by 2, I'll get the actual power. So divide by 2, 12.45. That is the watts, right? So that's way number 1, okay? Way number 2 is that let's don't use the peak voltage, right? Let's use the RMS voltage. So VRMS is V peak over square root of 2. So let's do that, right? VRMS, which is what we want to use for power, is 172 over the square root of 2, which is 172 divided by the square root of 2, 121.622. Okay, so that's my RMS, and now I can just find the actual power using VRMS, right? V squared over R. So this works, this gives you the actual power if it's the RMS power, right? So that's 121.622 squared divided by 12.2. So I'm going to square that divided by, and I get exactly the same answer. It's 459. This is 12.459 watts. And of course, the reason it works the same is that you're squaring V. So if you've got the square root of 2 in the denominator and you square it, it's just, their net effect is just divide by 2. Okay. All right.